Alright, ladies and gentlemen, in this video we're going to look at section 10.2 dealing with the hyperbola. This is our second conic section that we're considering. And to view this as a conic section, again, let's take two cones and stack them. And now this time when we cut them with a plane, we're going to cut straight up and down, parallel to the axis that this is on, in a sense. So cutting it this way. And the cross section here and the cross section here creates what's called the hyperbola. Okay? Now the geometric definition of the hyperbola, the one that we can actually use to construct a hyperbola, say on a sheet of plywood, and also to derive the algebraic form from, is the following definition. A hyperbola is the set of points xy, meaning points on a plane, such that the difference of the distances from xy to each of two focal points is constant. Now this is very similar to the definition of an ellipse. The only difference being with an ellipse it was the sum of the two distances that was held as a constant. Now it's the difference of the two distances. So if we envision this on a plane, and I place the focal points here and here, so that's the point C0, that's the point negative C0. A point xy to be on the hyperbola means that this distance, d1, and this distance, d2, when subtracted, are going to be constant. Now, to write that as an algebraic equation, we write the following. Okay? d1, this distance here, x minus negative c squared plus y minus 0 squared, square rooted, minus d2, x minus c squared plus y minus 0 squared is a constant. And again, we'll write that a constant like we did with the ellipsis, 2 times a. It makes the arithmetic come out simpler. So here we have, when we simplify, x plus c squared plus y squared, square rooted, minus x minus c squared plus y squared, square rooted, is 2a. Now, to isolate one of these, I'll just add this square root to both sides. And once we've done that, once we've isolated a square root, now it's okay to just go ahead and square both sides of the equation. So I get x plus c squared plus y squared. Over here, when I square this binomial, I get this squared. This times this twice. Plus this squared. And of course, the y squared here and the y squared here cancel. But also, if I expand out the x plus c, and I expand out the x minus c, I get a cancellation of the x squareds and of the c squareds. Alright, now let's group some terms together. Let's see. Let's take this 4a squared over to the left. And let's divide, or let's also take this negative 2c squared over to the left by adding another 2c squared to make that a 4. And then finally, let's divide by 4a. And that gets this square root isolated. Now I can square both sides of this. Now, in here you could cancel the 4's. So I'm really squaring cx, c squared x squared. This times this twice, and then this a squared squared, all divided by a being squared. And over here, we get rid of the square root. Alright, I already need another sheet of paper. Alright, so c squared x squared minus 2a squared cx plus a to the fourth all over a squared equals, over here, x squared minus 2cx plus c squared plus y squared. Now let's multiply both sides by this a squared. 2a squared cx plus a to the fourth is a squared x squared minus 2c a squared x plus a squared c squared plus a squared y squared. 2a squared cx, 2a squared cx, those cancel. Now, everything that has x's and y's, let's bring over to the left. Everything that doesn't, we'll put it on the right. C squared x squared, this a squared y squared, and this a squared x squared come over. That takes care of that, that, and that. And that leaves this a squared c squared and this a to the fourth being subtracted. Alright. So what do I see here? Common x squared, pull that out. You get c squared minus a squared x squared minus a squared y squared. And over here, if I pull out an a squared, and looking at that, what I realize, I've got a squared like here, and c squared minus a squared like here. So if I were to divide everything by a squared and c squared minus a squared, all these will cancel over here. Here the a squareds will cancel. And here the c squared minus a squareds will cancel. So you get x squared over a squared minus y squared over c squared minus a squared is 1. Let b squared equal c squared minus a squared, and you've got the standard form. Where b squared, of course, was c squared minus a squared, which means, remember, the c is how you're going to have to find the focal point later. C squared is add a squared to both sides, a squared plus b squared. You add the two denominators together to get the c squared and locate the focal points. Okay? Alright, so there's our standard form for a hyperbola. Now let's take a look at some of the exercises and see how we work with this. In number 6, 3y squared plus 2x equals 6. The question is that a hyperbola? No, it's not. The x is not squared. In number 8, is that a hyperbola? 5y squared plus 4x squared is 6x? No, it's not, because you have an addition between the y squared and the x squared. I need a subtraction. If it's an addition of the two, that's an ellipse. And 10. Negative 9x squared plus 18x plus y squared plus 4y equals negative 14, or minus 14 equals 0. Is this a hyperbola? Well, yes, because you have the positive y squared and the negative x squared. That's a hyperbola. Okay? And in fact, if you were to complete the square, you could get the form of this hyperbola. Alright, let's take a look at problem number 12, where the author asks us to write an equation for the hyperbola in standard form, if not already, and identify the vertices, the foci, and write the equation of the asymptotes. So I'll show you what that means. In number 12, we have x squared over 100 minus y squared over 9 equals 1. So definitely we have the x squared minus y squared. This is a hyperbola. Okay. Now the focal points, remember you add the two denominators to get the c squared. Okay. The vertices, that simply is where does this thing cross an axis? Well, when y is 0, x squared over 100 is 1, which means x squared is 100, which means x is plus or minus 10. So those are vertices. If x were 0, this term goes away. You'd have negative y squared over 9 is 1, which means y squared would be negative 9, which means y is imaginary. And that is not going to appear. Right? Negative 10 and 10, those are real numbers. So those are vertices. You have vertices for the long one, right? For the large denominator. That's what tells you where the vertices are. The focal points are now going to be outside of those vertices. So the focal points, instead of going 10, go square root of 109, which is a little bigger than 10. And those are the focal points. Okay? And now the shape of this thing is the following. And what it's following is guidelines drawn like this. In other words, your curve, it tends to become linear as you go out. It goes along this line. And these guidelines are called the asymptote lines. Now the question is, how do you find the equation of those asymptote lines? Well, it's very easy to do that, in fact. When you want to find the asymptote lines for this equation, all you have to do is take that standard form that we have. This x squared over 100 minus y squared over 9 equals 1. And to find the asymptote lines, all you do is change the 1 to a 0. And now solve that for y. Add y squared over 9. Multiply both sides by 9. Take the square root. There's the equation of these asymptote lines here. This is the line y equals 3x over 10. And this line down here is y equals negative 3x over 10. Those are your guidelines. Very easy to find. All right, let's take a look at problem number 16 from the exercises. What we have here, y minus 6 squared over 36 minus x plus 1 squared over 16 is 1. Okay, that's certainly a hyperbola because I have the y squared minus the x squared form, but you'll notice we have shifted the center. The center now, just like we shift with any conic section or any equation, we've subtracted 6 from the y, we've subtracted a negative 1 from the x. So negative 1, 6 is where the center of this is. And so that means if when we're creating the graph of it, you're going to go to negative 1, 6, and you're going to say from there. That's how we're going to move to find the vertices and the focal points, okay? Now again, c squared is the sum of the two denominators. So c is plus or minus the square root of 52. Okay, the vertices are in the y direction because that's your large denominator. You're going to go up and down 6, up, down 6, up 6. And okay, the square root of 52 That's a little bigger than that. That's going to be 6 plus root 52, and this is 6 minus root 52. Okay? And now through that center, you're going to have guidelines. Oops, there's the center over there, sorry. Vertex, guidelines. From vertex to guidelines. How do you find the equation of those guidelines? Well, again, you take the equation of the hyperbola in standard form. Okay? And instead of a 1, you simply replace that with a 0. And now you solve that for y. Add this to both sides, the x's. If you want to take the square root at this point, you can. Multiply both sides by 6. Add 6 to both sides. And there you have the equation. So this right here is the equation of the line 6 minus 6x plus 6 over 4. And this is the equation of the line y equals 6 plus 6x plus 6 over 4. And you don't need to really rewrite those. You can leave them like that if you want. It's perfectly acceptable for me. And there you've got the guidelines. Okay? So, easy enough to find those, I think. All right, let's take a look at problem number 20, where we get to practice completing the square again. Okay, so we've got in number 20, 4x squared minus 24x minus 36y squared minus 360y plus 864 equals 0. Alright, so certainly I can see this as a hyperbola because I have an x squared minus a y squared term. Okay? Go ahead and complete the square. On the x's, take out the 4. And think about that. It's half of 6 is 3. You square that, you get a 9. I'm going to have to put a 9 in there. On the y's, take out a negative 36. Half of 10 is 5. Square that, you get 25. Now, how much did I add on the left so that I can add that on the right as well? Well, 4 times 9 is 36. And negative 36 times 25 is negative 900. Okay, so I had negative 900 here and positive 36 here. All right, so let's see. X minus 3 squared plus, I'm sorry, a minus a 6, y plus 5 squared. This is a negative 864. And take this 864 over, that's another negative 864. That gives me negative 1728. So I'm going to divide everything by negative 1728. And let's see, a negative 6 and a negative 728 cancel, making that a denominator of positive 288. And let's see, over here, get 432. And there's the equation of my hyperbola. Okay. So c squared is 432 plus 288. C squared is 720, so c is plus or minus the square root of 720. And it looks like the center of this, x minus a 3 is 3, y plus a 5 is a negative 5. There's the center of my hyperbola. So 3, negative 5, there's the center of it all, okay? And so your guidelines are going to go through the center. Now, which way is this going to open? Well, the y is the positive term. So it's going to open in the y direction, and that means I have to move from the center up and down the square root of 288, which is about 17. And that will be what I use to go to the guidelines to. The focal point, I'm going up and down root 720. And the equation of those guidelines, well, that's easy enough to find, right? You just change this 1 to a 0 and solve for y. So we have, when I change this 1 to a 0 and bring this over, y plus 5 squared over 288 is going to be x minus 3 squared over 432. So you multiply both sides by 288. And take the square root, and you subtract 5. And there you have the equation of this and of this one here. Okay? And that's all there is to that for finding those guidelines. All right, let's take a look at one problem where we just again specifically ask for the guidelines. 28. Y minus 3 squared over 3 squared minus x plus 5 squared over 6 squared is 1. Again, the approach to finding the guidelines is you change the 1 to a 0. Then you bring this x term over, so you get y minus 3 squared over 3 squared equals x plus 5 squared over 6 squared. And solve that for y. So you multiply both sides by 3 squared. Then you take the square root. So y minus 3 is plus or minus 3 over 6 is a half. X plus 5. Add 3 to both sides. And there you have it. If you want to write it out, you can. It's 1/2 x. Let's see, half of 5 is 5 halves plus 3 is 11 halves. And then when that's a negative 1/2 x. A negative 5 halves plus 3 is a positive 1/2. Those are the equations of the two lines that are the guidelines or the asymptote lines to this. All right, let's see if we can sketch the graph of a hyperbola. Number 34. 81x squared minus 9y squared is 1. So you want these in the denominator. So x squared over 1/9 squared, that is 1 over 81. Y squared, that 1/9 is 1/3 squared. Okay. 1/9 is bigger than 1 over 81, so you're going to have a little different shape to it. It's going to be not, your guidelines will be slanted in a certain way because of that. Let's go ahead and find c. C squared is 1 over 81 plus 1/9. That's 9/10 over 81. There's your c squared, so c is plus or minus the square root of 10 over 81. All right. Let us find the vertices. Now, when y is 0, x is going to be either 1/9 or negative 1/9. Those are your vertices. The c would be out here. And your guidelines will look like this. Okay. The equation of these guidelines, again, just go back up. Go back up to this and change it to 0 and solve that for y. Y equals 3x, y equals negative 3x are the guidelines. And you're done with the problem. All right, let's take a look at problem number 46. In 46, we're asked to, given the information about the hyperbola, find the equation of the hyperbola. And the information we're given is vertices at 0, 6, and 0, negative 6, okay? And focal point, 0, negative 8. Okay, so in other words, there, and there's a focal point. Now, you're going to have a focal point up here as well. Okay, so what we know here is that it's y squared minus x squared, 4. And I know that c squared is 64. And I know that a squared is 36. Because I know this is 6 and negative 6, that tells me that the a has to be 6 or negative 6. So a squared is 36. So 36 plus b squared is 64. So 46, 56, 66. B squared is 28, right? There's the equation of the ellipse. So not too hard to work backwards to these problems. All right, so let's conclude this video at this point. I know that you want to get working on your exercises, and as always, if you have any questions or concerns, just go ahead and shoot me an email so I can address it.